Good morning, everybody. First of all, my congratulations for actually getting here through the tube strike. And I'd like to welcome you to the third annual event that the OR Society has run on analytics. Today's event is Developments in Advanced Analytics and Big Data, 2014, of course. My name's Stuart Robinson. I'm president of the OR Society, about which I will say a little bit more in a moment. Just wanted to introduce a few things about today briefly before we go to our first speaker. That's right, okay, technology working. First of all, just to mention that, in fact, many of you may not have found it, but downstairs there is an exhibition today from a number of organisations who work in the analytics area, so do take time to have a look at that. It's actually where you've just registered and got tea and coffee. If you walk one room further, you'll find the exhibition there, and a little secret as well is they're serving tea and coffee in there as well. So you'll have a smaller queue if you walk one room further. But we'd like to thank these organisations for their support and for their exhibition for our event today. You will have seen the timetable for today. I'm not going to talk through it in detail. We'll let it unfold as the day goes through. But you'll be aware we have a range of talks and speakers today, people from the public sector, the private sector, academics and practitioners, all representing the broad range of the field of analytics and big data. We have a number of breaks during the day as well, and I think it's a real opportunity to network, to meet other people, and your challenge today is to talk to at least one person that you don't know during the day and learn more about what they do. All of the breaks will take place down the stairs where you just were, where you just registered, including lunch. And so do take time to network and meet with people during those sessions. Just mention that each of the speakers has been asked to speak for 30 minutes, so there will be time for questions and answers at the end of each talk, but also at the very end of the day we will have a period of panel discussion where each of the speakers will be sitting at the front here, and there will be a chance for a more extensive discussion and more general questions at the end of the day. So please do think about some of the questions you have, perhaps more general questions about the field of analytics and big data, and be ready at the end of the day to raise those as part of that discussion. Just a few words on the OR Society, the Operational Research Society, that's the organiser of today's event. You may have noticed actually at the top of the slides is our current logo, which is celebrating the Diamond Jubilee, the 60th year of the Operational Research Society. In fact, the Society has a slightly older heritage in that, because prior to that it was known as the Operational Research Club, but in 1953 it became an open society. For those who know little about operational research, it's worth mentioning what operational research is. It's the application of advanced analytical methods to improving an organisation, and very much, therefore, ties in with the field of analytics. And certainly those of us who've worked in operational research over the many years recognise that what we do is apply analytics to organisational improvement, and therefore the theme of today. The OR Society's aim is to foster and promote the field of operational research, to build networks of professionals. We publish a number of journals, run conferences and events such as these. We encourage professional development, and we also promote the benefits of OR. For example, we have websites on the science of better, explaining what operational research is. We work with schools in promoting operational research and analytical methods, and we also have a scheme for pro bono OR, where people deliver obviously free consultancy effectively for particularly charities. If you want to know any more about what the Operational Research Society does, we have a stand in the exhibition, and indeed Felicity McClyster, who actually runs our pro bono scheme, is on the stand there. I'm told I know little about this myself, but you'll notice there a hashtag on the slide. For those of you who wish to tweet today, I have tweeted occasionally myself. I'm told please use that hashtag to promote today's event. I'd just like to finish by saying thank you to these three people. You'll see them around today. The two Johns, John Ranyard and John Hopes, and Hilary Wilkes, all of whom have put a huge amount of effort into organising what is an excellent programme, and I'm sure an event we will all very much enjoy. So thank you very much to them for all of their efforts. A couple of general announcements. First of all, on health and safety, I'm told there are no expected fire alarms today, so if it does ring, it's for real. And I'm told what we should do is just go down the stairs and pretty much opposite walk out into the courtyard by where the registration area is, if that happens. In terms of amenities, there is a bathroom actually in the corner here. If you feel shy about using that during a talk, then downstairs, just beyond the registration, just beyond where the exhibition is, there's another bathroom down there. Okay, what I'd like to do immediately is move on to our first talk for today, which is Sayara Beg. Sayara has 15 years of experience as an independent consultant working in business intelligence and data warehousing. And currently she's studying for a PhD at Birkbeck University, looking at fraud detection using machine learning and game theory. Sayara is well known to us because she's also chair of the Operational Research Society's Analytics Network, something on which I'm sure she will tell you more during her talk. So I'd like to hand over to Sayara, who's going to talk about data science, OR best practice and governance in analytics consulting.
My first degree was in Operational Research Decision Sciences. My second degree, my master's degree, was in Information Systems Analysis, which is where I was introduced to data modelling, data warehouse, data modelling, and SQL as a language. I'm also a qualified barrister, and I specialise in risk and compliance reporting for a number of industries, and more recently for one of the top tier banks. But when it comes to reporting business intelligence and data science, as it now is, there's quite a lot that I've picked up. I've noticed nuances to the way we used to do reporting using business intelligence to what it is now with big data and data science. And I'm going to hopefully give you some of that insight as to what I think data science is, what I think OR is trying to do about it, and why you should be with us in pursuing that further. So, very quickly, I'm going to talk to you about what a data scientist is, what it does, and some of the best practice issues, some of the unintentional mistakes. Are they unintentional? Were they fraud? And the two issues facing a data scientist today, the question of reproducibility and applying the scientific method. So, quick show of hands, what came first? Do you think it's the data? Quick show of hands. And how many here thinks it was the question? Okay, more people towards the question, but it is still an ongoing topical discussion. What do you think of first, the data or the question you're trying to answer? So we'll explore that in a bit when we talk about what the role of the data scientist is. The Harvard Business Review in 2010 announced it to be the sexiest job of the century, suggesting that this person was a superman, or woman even. Is it a mathematician, a computer programmer, a graphic designer, or is the data scientist all of those rolled into one? Is it a tedious job? The Harvard Business Review in 2014 most recently said that the data scientist's job is tedious. majority of the scientific analysis time is spent doing data discovery, data wrangling, data munging, which is transformation, data cleansing, data profiling, and a lot less time is spent modelling and visualising the results. Is that a tedious job? So what does a data scientist actually do? Well, there is an expectation that's been set by the media that a data scientist is a scientific expert of some sort, has knowledge in statistics, mathematical problem management, operational research modelling, even physics. The crux of the message here is the need to identify algorithms to use, gather insights, discover patterns and clusters. But do you really need a PhD to do this? And yet, when you see the job specs that are put out there by the majority of the recruitment consultants and employers, there seems to be a standard response: a PhD is required. The tools of the trade for a data scientist is the data, the hardware, and the ability to do software programming. Why is that? Well, ultimately, as a data scientist, you need to access that data, and the majority of that data is in various types of hardware. Hardware that we will see a little bit later on are sometimes termed as Hadoop, sometimes termed as MongoDBs. Are you aware of these hardwares? There is software that's needed to capture, extract, prepare and cleanse, software that was predominantly known as access in SQL and now known as R. Do you know R? And then there is the interpersonal communication skills that have been demanded from a data scientist, the ability to communicate and present those results. And the emphasis is on the visual communication using colour, shape, size and quantity. So that's leaning towards that graphic designer capability to visually represent some of those results. And we will see a little bit later some of those infographics that tend to be used to present some of those results. Could you call yourself a data scientist knowing this is what you would need to do? So let's have a look at that analysis. Most of us who do any form of reporting using large data, especially in the field of business intelligence and data warehousing, would be familiar with the SQL, structured coding, as a means of extracting that data. It's very simple code here. We have a tabular set of data, and we've got a very simple SQL code. Select ID, name, registration date, address from table employee and group by name. A lot of the people today in industry are able to use SQL. It used to be a knowledge that existed within IT departments alone. But as that ability to access data and understand it moved from IT into the business, a lot of data analysts sitting within the business area have taught themselves SQL to access that data and to get a feel for it. Now, if that transition has taken place for SQL, what's the next language that will be expected? Exploratory data analysis. Have you heard of this? This was introduced by Tukey in 1980 as a means of using a number of algorithms to get a feel for data. Those algorithms would generate visual results. Using the visual graphs, you got a feel for what the data was telling you. Now, this isn't so much as presenting or modelling or visualising the data. This is really the extraction, the capture, the profiling, the munging. Throw various bits of algorithms towards this data to identify what it is that you're working with. Now, in my own experience, the number of times I've had to use SQL to actually do that is probably quite common. As I worked in IT, it was something I had to do in IT. Over the years, I noticed that the business analysts sitting in the teams within the business were beginning to write their own SQL code. They were interrogating a very large database and writing their own SQL code. And my role in IT will be to support them through that.
So as the knowledge transferred from the IT expert to the business expert, I was really there helping them understand whether their coding was right. Now I'm beginning to see a lot of business analysts in the business starting to teach themselves things like R. And I'm finding that I'm having to review their code and assess if they've actually got it right and if they're understanding the results. Again, in business intelligence and data warehousing, a lot was started off with structured modelling of data. Coddon-Date introduced the concept of third normal form, and then we moved towards dimensional modelling. And this is all to really bucket the data in a way that made the SQL coding over the data a lot more accessible. Why has that changed now? Well, now it's big data. What's big data? It's unstructured. The time that one spends to try and model big data is the equivalent of trying to boil the ocean. Where do you start? What do you look at? How do you model it? How many star schemas and snowflake schemas are we going to have to design? And plus, structured modeled data was originally kept in relational databases such as Oracle, such as RDBMS, even Access and SQLite, all very accessible to the ordinary person. If you were to buy Microsoft Office, you often got SQL Server available as part of that package, or you could download SQLite, put it on your laptop at home, and create your own relational database. We're moving away from this now because you cannot model unstructured data effectively. So, what's this landscape looking like? I'm not sure if you can see that, but I'll talk you through it. A lot of the technologies, as before, was around structured databases, Oracle, RDBMS. A lot of the analytical tools that we've been dealing with business intelligence and data warehousing has been with tools such as Business Objects, Cognos, Brio, some of these tools you may be familiar with. Now, when I first started out in industry working in business intelligence, the IT department would go and buy a Business Objects license copy. It would be on a CD, it would be delivered, and they would walk to the server, and I'd done that myself, and I'd put it into the server, press the install button, loaded it up, and made it available to the business teams. And then as I found, over time, the business were going out and buying the CDs of these software, installing it on their own desktops, loading up the data using Excel, CSV files, running their own modelling and visualizations. Now that's moving away because of the volume of data. It's no longer possible to store the amount of data that's out there on your laptop or desktop. The need to go back to the server is driving a lot of the analysis. The data scientist needs to understand its tools to be able to say how that data is going to be captured on that server to be made accessible for analysis. It's no longer easy for a business analyst in a business team to pick up the phone to someone in IT and say, I have a lot of data, I need access to it. Can you go and figure out what it is that needs to be done? Primarily because the IT team do not really know what data you want to work with. So often the requirement is the person who's doing the analysis needs to know how to capture that data, store it, and work with it. And what is big data? Well, if we look here at the beginning, where it's ERP, if you can see it from a distance, big data about 20 years ago was that. That's what we knew it to be. As we grew over time, we started to get involved with CRMs, customer relationship management tools. Our knowledge of what data we wanted to work with grew with it. As time has increased, we've moved to web data, and now we're moving to a lot more sensor data, pixel data, data that's no longer within our ability to imagine and visualize in our head. How did we visualize data before? You've probably all been involved in producing these sort of reports yourself, if not have asked somebody to produce it. So very tabular, very structured, column-based, row-based, with some colour coding. with lists, with sums, with averages, all very simple, all very easy to navigate. But how many of you have worked in an environment where, as I have, you've had to collect reports from different areas to compile your summary report? Now, I had a particular assignment where, for a larger organisation, it was multi, it was global, we had countries that were producing reports. A quarterly Exco pack was being produced, it was about 50 pages long, and it involved having reports very much like the ones with pie charts there, from every single country compiled together and a summary put on top. Now, every time I received some of these pie charts and tables, I had no supporting data behind it. So I had to ascertain what made that cell red. What was the condition behind it? How do I interpret that spreadsheet with the different colours? How do I identify that that's a bad number or a good number? Is it red because we've exceeded a threshold? Or is it red because we've dropped a threshold? None of that information came with the Excel spreadsheet. So I had to try and ascertain that data behind the Excel spreadsheet to work out if that was telling me that something's good, bad, or ugly. So my ability to reproduce that data and then provide a summary sheet for the executive board, summarising on a country basis, was challenged because all I had was a spreadsheet with a colour-coded section. Now, if visualisation is changing, and it's changing towards being able to tell a story in 20 seconds, we have new ways of representing that. We have pictures, we have diagrams, we have shading, colour shapes. How am I going to read the data from these types of visualizations to produce a summary for somebody else? So if we take this here, this is a very typical politics split between left and right. Every diagram on there indicates an opinion, a population's opinion, whether they're leaning towards left, leaning towards right. Now, if I had to compile a summary and I received a report like that from every single country with no supporting data behind it, how do I reproduce that report or even authenticate that it's telling me the right thing? How do I validate that it's correct? So visualization may have improved, it's become prettier, there's more infographics, it's a lot easier to read by the eye, but is it making it easier to reproduce? Can you question its authenticity? Which leads us to the question of best practice. Now, as a data scientist today, the requirement is very much, we need someone with a PhD, we need someone who knows about all the big data technologies, Hadoop, Mongo, some of the new ones that are coming along. We need someone who can do R, Python, Java, and we need someone who's very good at representing themselves visually. Okay, that's great, but can they apply it using a scientific method? Can they authenticate the results? Will it be peer-assessed? Will it be reproducible? So the word scientist in the title data scientist, I believe, is not being fully validated. It's very easy to call yourself a data scientist, but are you applying the scientific method? So let's have a look. What is science? The Science Council have provided a definition on their website. Science is a pursuit and application of knowledge and understanding in the natural and social world following a systematic methodology based on evidence. And that's the word I'd like to follow, systematic methodology. Are the data scientists of today applying a systematic methodology? Well, let's take a step back. Let's have a look at what's gone wrong by various data scientists. The Reinhart and Rogoff scandal of 2013, which you may be familiar with. They published an economic paper in 2010 where they announced that 90% of debt to GDP threshold excesses slow economic growth. This was a substantial paper. It was taken on by some of the major organisations around the world, including the World Health Organization. and they lent on this paper to make some of the fundamental decisions globally. In 2013, two professors and a student, primarily a student, discovered that he was unable to reproduce the results in this paper. Went back to Reinhart and Rogoff and asked for the actual data. Can you show me the data supporting your assumptions here? And discovered fundamental coding errors and missing data. It was very simple. There were 20 countries, and a simple select down the cells, 5 were missing. When the 5 were automatically included in that sum, it made a significant change in the real average. The Ponty scandal of 2010 at Duke University, where it was abundantly clear that there was manipulated data behind the published research. So research that was put out there, published and accepted, but when it was reviewed and attempts were made to reproduce it, there was manipulation of data. And we've had a number of other scandals that have come out. The Ponzi scandal leading to the Madoff collapse, the subprime mortgage leading to Lehman Brothers collapse, the accounting frauds, Enron and WorldCom collapse. What was going on behind there? Manipulation of data. The Daily Telegraph run a Climategate blog, and they alleged that climate change is the worst ever scientific scandal. Why do they allege that? There are lies, damn lies, and then there are statistics. Statistics allows you to work with data in different ways. The same data can give you lots of different figures. But if you do not stipulate how you're using that data, why you've used that data, you leave yourself open to all sorts of criticisms. Were these unintentional mistakes, or was it a deliberate manipulation of data? In some cases it was deliberate, and perhaps in some cases it was unintentional. But if they'd applied the scientific methodology, would that have cleared them, those that claim it was unintentional? So it comes down to reproducibility. How do you demonstrate that the results that are published out there can be reproduced, can be authenticated and validated? What are the challenges for reproducibility? You produced a report, you sent the report to an intended audience who may have specifically asked for it, and now you're being questioned about some of the figures. So you say, okay, 2 or 3 days later, you go back, and suddenly you're unable to reproduce the same report. Why is that? Well, fundamentally, it's because the data itself is not static. And this is often overlooked. Its meaning and value is fluid. What it meant today will mean something else tomorrow. If we take a very simple, let's take a very simple bill, a bill of an energy company, so it's been reproduced. You look at the bill, it has a number on it. 2 or 3 weeks later, that number will change. Why? Because perhaps there was an error at the time of the bill, perhaps you were overcharged, perhaps you were undercharged, perhaps it was based on an estimate, not on an actual. So someone's gone back into the database, put in some corrections, amendments, cancellations. Now you try to run the same report, and you're consistently getting a different number. How will you go back and reproduce the same number that was generated in the bill 2 or 3 weeks ago? Because data has moved on. Analytics is often done based on a moment in time. And it's again, that moment, that was the question being asked, that was the report being produced. Is that question still valid? Do you still need to know that information? And can that moment ever truly be reproduced? This is a very common problem that I face in a lot of the work that I do for clients, where very commonly in sales, there's been all sorts of sales reports generated, but data has moved on, reports have moved on, and the actual report that was generated however many weeks or months ago was not frozen in time, nor was the data supporting that report frozen in time. And as a result, many, many weeks of time and effort is spent trying to reverse engineer the data just to reproduce the report. And after a while, you start to wonder whether there's any value to doing it. But if the scientific method had been applied, and the question of reproducibility had been addressed. And when that report was published, the data behind it was also frozen in time, put in one side, to be made available whenever that report needs to be audited. Would that address that question going forward? The other fundamental and most often overlooked issue is the assumptions that were made at the time you were working with the data. So let's just look at that. You've got some data. It has gaps. Certain columns are missing, certain fields are missing. You've made an assumption, you've made an interpretation. You perhaps entered your own values where it's missing. You perhaps made an assumption that it fits a certain profile. Time moves on, the report's been published, new questions are being raised. Where are those assumptions that supported what you did with that data to produce those results? How can you point back to it if you've not written them down and you've not had them validated? So analytics is becoming a lot more scientific as more and more questions are being raised. And as we've seen, more and more high-profile scandals are being brought to bear because fundamental decisions are based on analytics that have been produced, and yet the question of reproducibility is not really being addressed. The validations not only must be written down, they must be robust. They must be second opinion. You may have a view, but did you ask somebody else if your view is right or if there's another view? It's important to be able to point back to them and say, at that time, that was the assumption I made with that data, and I had it backed up. So, if we was to look at the scientific method, what would that mean? If we were all to embrace the scientific methodology in our analytics, what would we be doing? Well, we would, of course, state our assumptions. We would articulate our questions and we would establish the hypotheses before we start. The question comes first. We'll then write out what we intended to do to answer that question. We would make our own extrapolations as to what we would expect once we followed those steps. Then we would actually document the results and highlight the differences between what we've actually found and what we expected to find. And did you get someone else to validate it? Now this is the scientific method. The Science Council, when it suggests applying a scientific methodology based on evidence, it is stating that these are the steps you would follow. Going back to the high-profile cases that proved to be fundamentally error, did they follow this? Had they followed it, would the Reinhart and Rogoff scandal have been no scandal at all? Would they be able to point to their assumptions and state, we were clear, we deliberately did not include those five for these reasons, and we had someone else who supported our opinion? Would that have had a different effect? So you may be a data analyst, but are you a data scientist? Now, the OR Society has recently been granted a licence by the Science Council to offer the Chartered Scientist registration. It's something that I think the OR Society is quite keen to hear from its members and people like yourself in the audience. If it's something you would be keen to embrace, you would be peer assessed in how you do your analyses and other types of analytical work. You would have to do continuing professional development to make sure you're up to date, you're embracing the latest tools, technologies, and whatever's being demanded out there, and you're up to speed with it. And effectively, it could demonstrate that you can be authenticated in your work, and this has been peer assessed. Is this something you would be interested in? If it is, there is a feedback questionnaire. Make your statements. We would be very keen to hear from you. Okay, that ends my speech. Let's take it on to questions. Any questions?
Okay, in terms of questions, we have a couple of roving microphones.
If you indicate a hand, and then we'll pass the microphone, just say who you are, where you're from. Yes,
Is he going? Excellent. Name's John Ryan, I'm retired, but still nosy. Three thoughts that came to my mind as you speak. Pretty pictures come up. Number one, how about the handicap, particularly the visually handicapped? How can you get that information into somebody who's blind, either totally or something like colour? Secondly, a lot of symbolism you talked about. Should you think about standardising the symbols so we can teach people the language so they don't have to spend half their time finding out what they're looking at? But the other thought is, are we looking at the argument, are you a technologist or a scientist? If you like, the technologist takes an affirmative approach, we know it works, so I might do it again and again and again in different places. But the scientist in the sense is, how can I be sure it's still working?
Right, three questions. Firstly, visual impairments. A lot of the reports that are being generated don't automatically consider that at the moment. But I think it does come down to the identifying who your audience is, and if there is an individual that is known to have certain issues and a report needs to be generated for them, I think other things are taken into consideration. I don't have any examples specifically that I can talk to you about, but I would like to think that if it is known that there is somebody who has a visual impairment and needs special assistance, something will be done to accommodate that. The second question, symbolism? And whether, sorry, can you remind me the second question?
You look at your picture, you have little symbols that shows...
standardisation.
Obviously, we're talking about population or temperature or something. Should we be standardising these things so you'll learn the symbol language as well as letters and numbers?
Yeah, I agree. I do think there is a need for standardisation. I think the need for standardisation cuts across a number of things. So not only the ability to identify certain tools for certain activities, certain languages for certain things, but if we are going down the visual representation of data, yes, there is a need. Do I have the full answer as to what it should be today? No, but I would like to put that out to the members of the OR Society and say, be actively involved, start putting some ideas together and let us know what we can do as a society for yourselves in that area. But I do think governance is a very big issue and that could fall under that. And the final question was...
Technologist plays scientist.
Right. I don't have the full answer to that one, but I would say if you're a technologist, you're still a bit of a scientist. Hopefully I've knocked that one on the head. Any other questions?
Can I just ask, I could be greedy, I've got the microphone, so I can ask the question. You nicely set out the scientific method, which is something that both as an analyst I was taught and I actually now teach. I do have this question, you asked, does the question come first or the data? But the world in which I was brought up in, learnt in, and the world in which the scientific method evolved is a world where there was very little data. So we were forced to ask the question and then find the data. And something I'm raising the question of really is, does the new world where there is plentiful data actually suggest we could have a paradigm shift in terms of the scientific method, and actually maybe the data should come first, and then the question?
It's an interesting question, but what I would say is this: where we once had no data, and we had to ask the question to identify that data, we're now in a complete opposite where we have so much data that it's almost as if we're still blind, and that we still don't know where to start. It's so big, it's beyond our imagination, that we still can't see it. So it doesn't, when you look at the volume of data, it doesn't lift out by itself naturally what you should be picking on first. So I think it's still the case that we ought to be asking the question first, if only to help us towards reducing the unbiasedness that we're getting with the big data, and to address some of the noise and dirtiness that's in big data. Because we can be so heavily influenced by that, we still need to be sure we know what question we're asking. The trap that you will fall into if you don't have that question first is correlation causation issue. You might suddenly identify a pattern in this huge amount of data, and it might look like the two are related, but without further information, without exactly knowing what question you're trying to answer, you'll simply lead to an assumption that X happened because of Y. There is an example, and I don't have the full details, of a research that took place where increase in sales in ice cream led to an increase in drowning. And the research fundamentally suggested just because there was an increase in the two, it didn't mean if you bought an ice cream you subsequently drowned. It simply meant that it got hotter. More people were buying ice cream, more people were swimming, more people were buying ice creams in these swimming pools. That without that extra information, you'd automatically lead to the assumption that X equals Y, and you won't really know why.
Okay, chance for a final question. Man in the pink shirt, back. Sorry, go and set you backwards.
Cheers, thanks. Robert Benny. On your reproducibility, I like the way in which you put that, but it seems to me that if, as you say, you explain your assumptions and the logic, then if the logic is able to be worked through again, then you can say, well, it's reproducible. At least the method is reproducible, and the classes of data can be sought, etc., even if you get a different answer. So maybe another way of looking at that is the ability to update that. And effectively you end up then with a model, which is an updatable model, which can be very useful in many situations, because that's exactly what people want to do. So that's really just a comment. Another comment really, or maybe it's a question, is there seems to be a huge fixation with data and big data. In some of the areas I've looked at or worked in, data is actually very sparse. If you take, say, future defence scenarios, then there isn't big data for those primarily. You have to sort of game them in order to generate data. So you end up creating synthetic data, which you then analyse. Obviously, you can see correlations with other things. If you go to the social sciences, again, I think you've got a problem, because if you look at something like benefits analysis and things like that, or people's dispositions to work and the like, the sort of things that the Centre for Social Research has done, then you will have some data, but it'll be slightly sort of around the problem, and you need to collect a lot more data. So you're in the business of data generation rather than data acquisition. I don't really want to comment on that, because I feel that there's a huge sort of swell of feeling that data goes first, or data and the questions go side by side, and that's all you need. But I think that you need a slightly broader way of generating additional data, sometimes quite extensively, in order to fill out the problem space.
Yes, I agree with you. There is, I believe, a misconceived belief that just because it's big data, it's fully populated data. That's not necessarily true, and I agree. It is sparse. Data is sparse. No matter how much you have of it, sparsity exists, still does. It existed 20 years ago, it exists today. What I would say is, because you do have to generate data to fill those spaces, the assumptions you make when you generate the data should be written down, documented, validated, peer-reviewed, because that's what's going to substantiate your results. It's not a case of what you do is right or what you do is wrong, because it's never as clear-cut as that. It's simply the case of saying at that time, when you generated those data attributes to fill that sparsity and the assumptions you made at that time, one, did you get them validated by somebody else and could someone support that that was a way to go? And two, have you actually written them down anywhere for anyone to look at and reproduce? So I think turning the question back on its head, it's not a case of have we not covered it? I think it's there and it's still there. The issue is still there. Data generation is a fundamental part of the data analyst's job, or any analyst's job. But it comes back to the question of reproducibility. What assumptions did you make at that time when you generated the data? Did you write that down and did you get it validated?
Okay.